Precalc 8.2 systems of two equations, two unknowns. So we're just going to quickly go over the first two types. There are three types we talked about on Thursday, I guess it was. There are systems with one answer, which would lead you to a picture that looks like this. They cross. No solution, which means they're parallel but never touch. And all solutions are infinite many solutions if they're parallel and happen to be the same line. So we can be inconsistent, dependent, we can be consistent, and different things. Okay, so there's multiple things. I'm not going to worry about inconsistent, dependent, all of that. We did talk about that in Algebra 1, if you remember. But a lot of this we've been doing now for the last 3, maybe even 4 years for some of us. You don't necessarily need to write that down. We all know that. So let's just go into one example of each. There's going to be a slight difference for the third case, and the third case is infinite many. Back in Algebra 1, you saw, hey, infinite many solutions. You dropped the mic and walked out, right? You walked out. We're not going to do that today. Today we need to set up a way so that I can find any solution that I want based off of some information. And then we'll go into some more modeling with equations, aka word problems. So, I'll give you guys a couple seconds here. It's not going to take long. One solution. Solve it. So, elimination, substitution, which one? Substitution was said earlier too. And I think elimination would be just as easy. Obviously, they both work. The reason I think that substitution is nice is because everybody should be able to see that y would equal 3x, right? But the other part is when I do elimination and I solve for a variable, I have to put it back into one of the original problems. Versus with substitution, I have a second or a third equation, we'll say, our option that I can already put x back in to solve for y. So that's what I kind of like substitution for. Not always the easiest option though, or most efficient, sorry. So, we should have 5x plus 2 times 3x equals 22, or 5x plus 6x equals 22, or 11x equals 22, or x equals 2. We plug that back into there, and y is equal to 3 times 2, which is 6. Bless you. You're not officially done because you need to place it as 2, 6. We have an answer. It's an ordered pair because it's a point of intersection. Not that big of a deal. All of us should be pros at this by now. Moving on. This one should be no solution. When we say no solution, what should our algebra show us then? What are we looking for? 0 equals 1. 5 equals 4. Something that doesn't seem to jive, right? Make it happen. Elimination or substitution? I think elimination would work best. And are we going to eliminate the x's or the y's? Well, it's going to happen to be both in this case. Yes, I understand that. But looking at the problem, my first instinct would say get rid of the y's. Notice that either way, one of them is positive, one's negative. So I just need to multiply the top one by 3, the bottom one by 2. 24x minus 6y equals 15. And negative 24x plus 6y equals 14. Oh, gone. L is 0 equals 29. No solution. No solution. Done. Easy enough. So then try the next one, guys. The next one, I'm telling you, it's many solutions. For now, just get to the point where you can say, I know that there's infinite many solutions, and then we're going to come together, we'll do that, and then we'll show us what we need to do from now on out. Okay. Elimination or substitution? I'm thinking elimination. Getting rid of x's. So one of them needs to be multiplied by negative, so let's just do the first one. Negative 4 and a 3. That'd be a negative 12x plus 24y equals a negative 48. 12x minus 24y equals positive 48. And cancels, 0 equals 0. Then we're like, oh, that's infinite. Many. Those dots didn't come through very well. Okay, infinite many solutions. We used to be able to drop the mic, walk out of the room, saying we're done. Today we cannot do that. Today, what we're going to want to do is we're going to want to make it so therefore I can find any solution really efficiently. And what I mean by that, instead of saying it's x, some random xy pair, I'm going to ask you to call the first one x, but I want the second one, guys, in terms of x. So I want you guys, as soon as someone said, hey, x equals 2, could you tell me the answer? Can you tell me what solution would exist with x equal 2? Yeah. And then go and say, hey, what happens if x was 10? What would the y have to be? And so this is easily done by going back up to any of our two equations above and solving for y. Because when I solve for y, y will be in terms of x, which is what we want. So, which one's the smaller equation? I would say the second one. Or the first one I meant, yeah. So negative 6y equals 12 minus 3x. Is everybody okay with that? Already starting to solve it. Divide everything by negative 6. Of course, I'm not going to leave it in that form. I'm going to clean it up a little bit. What would that be? 1/2 x plus 2? Oh, minus 2. Minus 2. That piece is what goes in here. Because now, what if I said, hey, I got the point 4 comma what? 4 comma what is the answer?
0.
0. I could put 10. 10 comma?
3.
Half of 10 is 5. Minus 2 is 3. So we can keep coming up with more and more ordered pairs that work. There's an infinite amount. As soon as you find one, I'll find one. And then someone else will find one. Make sense?
Yep.
If there's an x, y, z, which is coming up, there very well still could be an infinite amount of solutions. You can still list it as x, some y in terms of x, and z in terms of x. So it takes a little bit more time to set that up, but it is all possible. That's new stuff for today. The rest of it was all old stuff. What's more new stuff? More new stuff is modeling with systems of equations. You guys don't have to write all this down. This is almost the same exact setup as we had back in like 2.3 with the Foxton problems. Careful, because guys, the Foxton problems ended up being systems. Okay? Basically, you identify variables you're using, express them in some kind of equations, you set up the system so you can solve for the unknowns, and then make sure you answer the question in part 4 that says, hey, just because you found that it costs $2 a cookie, the question might be asking, how much does it cost for 10 cookies? Okay? That type of thing. Be very careful on that. Don't have to write that down. Just know it. So, we affectionately will do one of these problems that you guys loved last year. A distance speed time problem. A woman rows a boat upstream from one point on the river to another point 4 miles away in 1.5 hours. The return trip, traveling with the current, takes only 45 minutes. How fast does she row the boat relative to the water, which means how fast can the boat go in still water, and how fast is the water? Who's got the name for these problems from last year?
Distance, speed, time.
No, it's not a distance, speed, time problem. It was a boat.
Cruise.
Boat in the river problem or water problem.
I'd rather call it a distance, speed, time.
And we kind of came up with our own little equations for this. Because we know something about, just from doing our last thing with vectors, that if I'm going with the current, the speeds will add together. If you're going against the current, you subtract them, right? So, I think everybody should agree that my rate up, time up, will give me a distance up. Yes? Can we solve, do we have any of that information? I think so, the very first sentence. What's our distance? 4. What's our time? 1.5 hours. Do we know the rate going up? We don't have a rate going up. But can we find it? And what would that end up being? My rate going up is
4 divided by 1.5.
4 divided by 1.5. You're right. Or 8/3. Are we okay with that?
Yeah, sure.
Okay. Can we do the exact same thing with rate down, time down equals distance down? What do we know about distance down? If we assume it's a return trip, it's still going 4 miles. Time though? 45? No, it's not 45. What should we change it to?
0.4. Nope.
Not
60 divided
0.45.
by 45.
45 divided by 60, or
Oh, yeah.
0.75. So we could say that RD, the rate going down the river, is 4 divided by 0.75, or you're divided by 4/3, or 3/4, meant, which multiplying by 4/3.
7 fours.
16/3 miles per hour. Those are both miles per hour. Would everybody be able to get the rates going up and down the river? I mean, it's right there given to us, right? But here's the problem. None of those numbers are what it's asking. But would we know about going the rates of the upriver and downriver? They either combine or they subtract from each other, right? Which one's which? Would you guys agree that the rate up is the boat minus the water? The rate down would be the boat plus the water? Do you guys remember the equations we used last year? You guys remember that?
No.
Boat plus water times time down equals distance down. Boat minus water, TU equals DU. I know I did that with my kids. This allowed us to just put things in. Because remember, last year's problems dealt with the fact that you were going 4 times the speed of the water, right? Or the air that was in. But anyways, we could combine them all at one time by placing these equations in for RU and RD. That means you would actually end up with these equations right away. But here's the cool things. I now know that 8/3 is the boat minus the water, and 16/3 is equal to the boat plus the water. Don't I just have a system now that I can solve for B and W, and B and W are what we want. Adding the two equations together, would you guys agree that is 24 4 over 3 equals 2b. Or 8 equals 2b. Or b is equal to 4. 4 miles per hour. That means that the boat goes, on its own merit, 4 miles an hour. And from there, you should be able to solve for W.
Yeah, it's taking a lot of steps to get to
Now, I'm going to use the second equation, but the second equation has 16 divided by 3. What is 4 in terms of thirds?
12.
So W should be 16 thirds minus 12 thirds. I'm speeding things up for us, which means that the wind itself is 4 thirds miles per hour. Or not the wind, but the water in this case. So we had it set up a system. We set up a little bit of beforehand work that allowed us to set up a system. We solved it. Done. So all of our problems today are setting up systems. Or at least half your homework. The other awesome problems that you guys so much loved were mixture problems. We don't have to do the chart on these. We're not going to use the chart.
How to do that?
Winemaker. Okay.
Can we just do like that?
This actually comes right out of your book. Now, the thing that I find sketchy about this problem, guys, is a guy who is fortifying wine with just an alcohol solution. He doesn't even tell you what it is. He's not even telling you it's another wine. He's just saying, I'm going to throw some other alcohol in here, and we're going to call it good. You don't know if it's isopropyl alcohol or what, but hopefully it's not. That'll make you sick. So, the guy wants to fortify wine that has a 10% alcohol by adding a 70% alcohol solution to it. The resulting mixture of the alcoholic strength is 16%, and it fills 1,000 1-liter bottles. How many liters of the wine and how many of the alcoholic solution did he use? So there's actually two equations in here. That's what we got to build. First of all, how much is going to be there? How much are we going to have? 1,000. Can we have more than 1,000?
No.
Can we have less than 1,000?
1 liter bottles.
Overall,
Well, you could have
you can't have anything that differs but 1,000 liters of alcoholic solution
unless you
mixed.
drop
Now, what does that mean? What if I use X is my wine and my Y is the alcoholic solution added to it? X liters plus Y liters will have to equal 1,000, right? You can have 500 and 500, you can have 400 and 600, that's fine. But you have to, at the end, total up 1,000 liters. So we took care of the amount. We now have to figure out, how do we deal with the percentages? How do you deal with those percentages, guys? Bless you. Yeah, it's 0.10. 0.10x, because it's only 10% of that x value is actually alcohol, plus 0.7y equals 1,000 times 0.16. I put that at the end. I know I did. Why do we have to do this equation? The first equation was all about how much we had there. The second equation is all about how much what we have. What is 10%? What is 70%? What does that represent? It represents the amount of alcohol. So what we're talking about here is, in that second, the first equation is just the amount of solution. The second equation is just comparing the amount of alcohol in the first one and the second one and the final product. if we only are allowed to have 5 liters of alcohol in our solution at the end, the things that make it up, these two have to add up to that 5 liters. Obviously, we're going to have more. But that means there might only be 1 liter of pure alcohol in this one and 4 of the other. That's fine. But you can't have more than the total amount of alcohol in the system. We now have our 2 equations. We can put them together, or by the way they are, using substitution, or we can use elimination.
X is the wine and Y is the alcohol solution.
Yes. And I don't want to do this with these equations. Now, this particular problem is unique in the fact that you have a 1,000 liters. That itself kind of takes care of that decimal. Would you guys agree?
Mm-hmm.
But it's not always going to happen. So we're going to take care of this the old-fashioned way. We're going to act like that 1,000 is some other number right now. What do I have to multiply that second equation by to get rid of my decimals? Not by 10, but 100, because there are 2 decimals here. Again, this particular problem would take care of itself there, but I'm still going to multiply the second equation by 100. So I end up with x, or 10x, plus 7y equals 16,000. Can you guys agree with that? I am now going to put it together with the top equation using elimination. But the top equation I'm going to multiply by, oops, not 10, but yes, negative 10. So I'll get a negative 10x minus 10y equals negative 10,000. Put them together, gone. 60y equals 6,000. Drop out with 60,000 divided by 60. Y equals 100. That means x is 100 of the 70% solution, right? And then x would equal 900 of the 10% wine. Done. By plugging things back in. Any particular questions, guys? Homework, guys, for 8.2 is page 636, 21 through 29 odds. 37, 39, 41, 42. Have a great day.